So today is day 25, which we are working with time complexity of numbers which are prime and not prime. Um, First of all, what is prime number and not prime number? Prime number is just a number that has the divisor of only itself and 1. Yeah, it is a prime number. The other numbers, which can be divided by any number like including itself and 1, any number like 4 for example, it can be divided by 2 itself, which is 4, and then 1, which has 3 divisors, which cannot be representative of prime numbers. It is not prime. So it is like so simple solution when you look at it. Like, okay, I know how it's done. You just need to count down from n to 1 or from 1 to n in a for loop, and then divide each number by representative of I on the for loop, right? So this is that's what I did actually in here. In here, as you can see, I guess, yep. I'm sorry. In here, you can see what I have done. It's simply the same thing that I have told you. Like, I'm just checking in here. I'm just checking. Is it a prime number? Is it a prime number? What it does, this function does, checks the number. Is it below 0? Because if it's given a below 0, it is definitely not the prime number, or it is not the prime number, right? Because we can say we can check for the primality of the number when it's natural number, which is like above 0. So um, here, if it's below 0, we just say return false, which is it's not a prime number, right? And then the other option, which I have told you, from 1 to number we should be done, but as far as we know that 1 is excluded all the time, and then it can be divided by any number, we just say okay, it is from 2 including until number itself. So for I in range 2 to number in a range, we just check it. Is it divisible? Can you divide it? Yes. Then return false, which is it is not a prime number. And if this thing, everything in here does not work, you say, okay, it is a prime number, so return true, and then it becomes true in here, and then we say, yeah, it is a prime number. But here is the deal, guys. In our task, it is running time complexity, right? Running time complexity is notation on like big O notation and log n notation or theta notation, those kind of things, right? You just cannot ignore the fact that the n is runtime complexity of n is a lot bigger than n in square root. You see, that's why if you have an option to go for like this, like in square root of n, you better go for this all the time. If you can't do it, just go for it. And then most of the software developers, when they got into the job, they do not code from scratch. They do optimization like these things, all the running time complexity kind of things. So if you know it, just go for it. And then first I did not get it what it is, and I said, wait a minute, wait a minute. How to calculate the prime number if the solution that I've shown you in here is not the real solution, right? What is the way? So, weird way. I found this thing, like this Siev of Eratosthenes. I'm really sorry for misspelling the mathematical term. The single philosophy, the whole philosophy of finding the prime number can be represented on this GIF file, right? GIF image. So in here, it is so simple to understand, and then but it took me like 30 minutes to understand because I just read it without looking into it because I most of the time ignore the pictures when I read the Wikipedia page. But in here, everything is clear, and then I just come down and then I mean, read the down, and then when I look to the pseudocode, I'm like, well, okay, now everything is clear. And then the real action of everything that's being given in here is the same job as of this pseudocode. So what it does basically is you got the first number, and then find it is multiples until the n, like from 2. In here, the example is from 2 to 120. You just find all multiples. Okay? You just find all multiples. And then you took the first thing as a prime number, and then you switch to the next one. Right? In here. And then you find again all multiples. Like, okay, in here it is 6 and 9 and 12 and 15 and 18 until 120. Just see. Like it is just, yeah, it just doing the multiplication of 2 and then 3. See, it's just so simple. It's just so simple to understand because it's been chosen by 2 is not choosing the 6 again. So we're just going to skip, and then it's going to be like complexity of running time complexity is going to be like lowered down, and then at the end the magic thing is like the everything when it is like making it like this is explained in one word. If you read everything in here from there until to here, in here until to here, it is so simple pseudocode. And then it says this means that the algorithm will be terminated in step 4 when the p squared is greater than n. Yeah, from here it comes up to this all notation. Okay, so I'm just gonna close everything, and then because I have this running code already, I just have actually using the that Wikipedia, I just have written my own test case, and I'm just going to copy and paste because I'm lazy. See, and then I don't want to waste your time. I have not checked it yet, but I have to. Shit. Oh, I I almost had a heart attack. I'm really sorry. I forgot about this. Yeah, I forgot about int. Yeah. Woo! It is working. You see? And now it is working in square root of n, which is a lot more optimal than the previous code that I have shown you. If you understand these time complexity thing, and then if you know what you're doing while doing it, it is so fun. I mean, by fun I mean it is fast, right? It is fast, and then most of people look not into your code, but the optimality of your code. If you know what I mean, like when you are getting into the job interview and the other kinds. Have I prepared it? I was so excited about finding it out. That's why I think I have not yet prepared the materials, but it's not a big deal. I'm just gonna open it up and I'll prepare it and then push it. Guys, I do not want to take a lot of time. Just be sure when you are doing a code, first make sure it to work, and then make it as optimal as possible, because when you are going to work interviews, they look for the optimality of your code rather than it is working. And see you in the next one. Be in peace.